Hello students, today we will start our third unit. So the first topic is the plane stress. In a thin plate of thickness T with a hole in the middle is subjected to uniform tractional load. Okay, this 3D plate can be analyzed as a two-dimensional problems. The plane stress in thin plate can be analyzed as plane stress, where the normal and shear stress perpendicular to the xy plane are assumed to be 0, means stress in z direction is equal to 0, shear stress xy and shear stress yz is equal to 0. The non-zero components are stress in x direction is not equal to 0. Similarly, stress in y is not equal to 0. Similarly, shear stress xy is not equal to 0. So this is the plane stress. The plane stress is majorly used for 2D problem like thin sheet metal or plastic component. The assume 0 stress in z direction. For example, thin cylinder filled with fluid under pressure. Second example, thin plate with point loading or distributed forces applied over the thickness of plate. The next topic is plane strain. In plane strain, it is defined as the state of stress in which the strain normal to the xy plane, means strain zz, and shear strains xz and yz are assumed to be 0. Assumptions are realistic for long bodies in z direction, for example dams and tunnels. In plane strain, strain in zz, shear stress in xz, shear strain in yz is equal to 0. Valid for the plane strain is valid for components in z with the z dimensions is longer than the xy direction. Okay, so in same or end same, there is a question for to write a short note on plane stress and plane strain. So for this you have to write the definition for plane stress, plane strain, then write down condition, means which component or which parameter is equal to 0 or which component or parameter is not equal to 0. Then write down or first draw the diagram. First draw this diagram for plane stress, this diagram for plane strain. Then write down the equations for plane stress and plane strain. Okay, so these are the two equations. The question is for 6 marks, 3 marks for plane stress and 3 marks for plane strain. Then next one is axis symmetry problems. Axis symmetry elements are triangular such that each element is symmetric with respect to the geometry, and loading about an axis such that the z-axis, hence the z-axis is called as the axis of symmetry or the axis of revolution. Each vertical cross section of the element is a plane triangle. Next topic is the Pascal triangle. The Pascal triangle is majorly the polynomial used as a shape function for any element must satisfy geometry isotropy, and the term used in polynomial are given by Pascal triangle. If all the terms of particular order are included in the polynomial, it's called as a complete set. If terms are symmetric with respect to x and y, it's called as a geometric isotropy. In image, the first point or one number is called as a constant term. Second term is called as a linear term. Third term is called as a quadratic term. Similarly for cubic, quadratic. Okay, so in this Pascal triangle, For developing shape function of constant strain triangle, first two rows of the Pascal triangle are considered u is equal to a1 plus a2x plus a3y and v is equal to a4 plus a5x plus a6y. If the shape function of linear strain triangle is to be determined, we consider the first three rows of Pascal triangle, where u is equal to a1 plus a2x plus a3y plus a4x square plus a5xy plus a6y square, and in v terms v is equal to a7 plus a8x plus a9y plus a10x square plus a11xy plus a12y square. For for element not having geometric isotropy, then we consider the terms are u is equal to a1 plus a2x plus a3y plus a4xy, v is equal to a5 plus a6x plus a7y plus a8xy. Okay, so these are the important terms in unit number 3. The topics are plane stress, plane strain, axisymmetry and Pascal triangle. Okay, so in NSEM or NSEM this question asks for 4 to 6 marks on these topics. Okay, thank you.